Hello, and today we're looking at difficulties in predicting climate change. Now, when we're talking about predicting climate change, there is strong agreement between scientists that climate change is having an impact. However, there is less agreement on exactly what those impacts are and how bad they might be. And the reason for this is because it is very difficult to predict specific changes to our climate that are at a sort of scale that are meaningful for human beings. So you can say, well, the temperature is going to increase over the next 100 years, but how does that help a farmer know when a storm is coming, or a government plan on how strong they should set roofs to be under planning conditions to adapt to increased severity of storms? So it's quite difficult to make that specific prediction. And the reason for this is split into two things. We have natural factors and human factors that will affect how climate change develops at a sort of more useful timescale. Okay, so first one then, let's look at some natural factors. First one we're going to look at then is time scales. So this can be split into short term. So for example, sudden storms or a wetter winter, or it could be long term. So a trend in winters with increasing rainfall. So the next one then is spatial scales. So we can have impacts that happen at local levels. So for example, slower than normal moving storms, and this might cause local flooding. You can have regional. So you can have areas with increased rainfall in general due to increased evaporation. Or a change in wind direction. And we can have global changes, such as the general increase in global temperatures due to increased infrared absorption by the atmosphere. So global warming. So these two things, are spatial and time scales, can combine in different ways. So if we have some areas might receive more rainfall, whereas other areas might receive a lot less. If you have changes in one thing, so for example, if we had the UK, not very good at drawing UK, so bear with me. If we had the UK and it heats up, so it warms up because of increasing temperatures, so heats up, then this might mean that we have less summer rain because it's too warm for vapor to condense into precipitation. But it means that we could have in the winter, it's warm, still warm enough. So we have warmer means more water vapor. But now, because it's the winter, cold enough for more precipitation, which means that we end up with more rainfall. So this makes it difficult to say whether there will be more rain or less rain in the UK, because what we might find is a pattern emerging over time where we have less rain in summers with the resulting droughts and impacts on infrastructure and agriculture, but more rain in winters, which means things like floods occurring more often. Okay, so it's not necessarily a simple thing to answer. Next one we've got then is interconnected systems. So we do not fully understand the links between for example, biosphere, the atmosphere, the hydrosphere, and the lithosphere. Okay, so how elements and energy moves between these different parts of our planet is not fully understood, and it's not always very clear how changing one small aspect of this can affect anything else. So this makes it really difficult to predict things. And they can also be linked over different timescales. Which means that it's more difficult to see how the impacts will combine. And this is important because then this is what helps you predict accurately what's going to happen in the future. And if you don't know how they're going to combine, you're not going to be able to predict accurately going forwards. So as an example, in the UK, we might see, due to global warming, we'll see the following impacts. We'll see changes in the jet stream in the atmosphere, and this might raise temperatures. We might see a slowing of the North Atlantic conveyor, which might lower temperatures. And then we might see our global warming generally raise temperatures. So how do these interact or combine or change each other? And that would be really difficult to predict because of how they are interconnected with each other. And it will depend probably on the timescales that we are looking at. Next one then is natural fluctuations. So things fluctuate naturally in nature anyway. The climate has never been fully stable. That's why it's a dynamic equilibrium. The dynamic meaning moving, so it's changing all the time. Okay, and it's affected by different things. Solar output, which changes year on year, but has like a 7-year cycle and a century cycle and thousands of year cycles. The Earth's orbit changes. And also changes in Earth's surface. So how much vegetation, how much desert, how much ice. So these could hide or even exaggerate human changes. So this makes it difficult to link a storm with climate change. You cannot say this specific event has been caused by climate change. But what you can do is over time see a trend. So you can say it's been made more likely or more frequent due to climate change. And that's the language you'll see reported in newspapers if they're any good, or the news articles online or something like that, because they're reporting a change in a trend. And sometimes these trends only become obvious after a long period of time. So the last one then of the natural factors is our time delay between cause and effect. So the best example of this is the atmosphere warms quickly, but the ocean warms slowly. So the atmosphere warming will affect the ocean, but that effect will only be seen after a really long time. Okay, and this is because the ocean has a large volume and a very high specific heat capacity. Which means it can absorb a lot of energy before you see a change in temperature.